What's up guys, Metapunk here. Today I want to talk about the different generation cryptocurrency networks, starting with the early stage ones to the ones that we're more familiar with today. Alright, so let's get into it. So I have an article from Investopedia, and the way that they categorize the different generations of cryptocurrency networks. So you have generation 1, which is Bitcoin and the other digital currencies that were created around that time. And the main thing with these coins, it kind of gave notability to blockchain technology and also distributed ledger technology. And then down below you have generation 2, which introduced smart contracts to blockchain technology. And then down here you have the generation 3 cryptocurrency networks, and these are more known for their scalability and just overall efficiency. So on top of all these three generations, I actually created a generation 4, which I'm going to talk about at the end of the video. So here's a list of different generation 1 cryptocurrency networks. I didn't base them off of their network efficiency, I just based them off of when they were released. So the main thing with these cryptocurrency networks, they're mainly medium of exchanges that are peer-to-peer decentralized networks that really brought a familiarity to blockchain technology and decentralization. And the interesting thing about these generation 1 cryptocurrency networks, a lot of them have a proof of work consensus mechanism except XRP. XRP is a node-based consensus mechanism. And before I start this deep dive, I'm going to give a big shout out to Navigating Crypto because I use a lot of his posts for this video. I highly recommend you follow him if you haven't already. He posts a lot of good content, and I actually learned a lot as I followed him for the past year. So for each generation, I'm only going to deep dive into one of the projects for each section. So first I'm going to start off with Bitcoin. So Bitcoin is technically the first ever cryptocurrency ever created, and it was first created in January 2009 by a mysterious creator named Satoshi Nakamoto, and to this day we still have no idea who Satoshi is. And Bitcoin was first created right after the 2008 financial crisis, and it was seen as a better alternative to the traditional financial system at the time. So Bitcoin offered a promise of lower transaction fees than traditional online payment mechanisms, unlike government issued currencies, and also operated in a decentralized authority. So the fact that it was created in 2009, right after the 2008 financial crisis, the fact that it was a decentralized network that can't be controlled by any central authority, it was really seen as an appealing payment mechanism that people can actually trust. So there are no physical Bitcoins, only balances kept on a public ledger that everyone has transparent access to, and all Bitcoin transactions are verified by a massive amount of computing power, and that computing power goes into the proof of work mechanism that it was based off of. So the main thing with Bitcoin, it really introduced people to decentralization and also blockchain technology, and the fact that it runs on a proof of work mechanism, anyone can be part of the network and be a validator, and also has a really strong network. To this day, the Bitcoin network was never shut down or paused. So with these generation 1 cryptocurrency networks, the main terms to really know are blockchain, distributed ledger technology or DLT, decentralization, and also proof of work. So a blockchain is different from a typical database in the way it stores information. All blockchains store data in blocks that are all chained together. And then different types of information can be stored on a blockchain, but the most common use so far has been a ledger for transactions. And also decentralized blockchains are immutable, which means that the data entered is irreversible. For Bitcoin, this means that transactions are permanently recorded and viewable to anybody. So a distributed ledger technology is a protocol that enables the secure functioning of a decentralized digital database. Distributed networks eliminate the need for a central authority to keep a check against manipulation. A DLT allows for storage of all information in a secure and accurate manner using cryptography. The same can be accessed using keys and cryptographic signatures. Once the information is stored, it becomes an immutable database and is governed by the rules of the network, which is basically like the consensus mechanism. So for Bitcoin, it's proof of work. And the very nature of DLT makes them immune to a cybercrime, as all the copies stored across the network need to be attacked at the same time for the attack to be successful. So a DLT like Bitcoin is very secure in that way. It's really hard to attack it. And decentralization is a term used to describe a system that is not owned or controlled by a single entity, such as a government, bank, or company. Instead, the product or service is run and maintained using the computing power contributed by a global network of participants. So these decentralized networks are ran by the validators within the network. So if you're a miner and you're mining transactions, then you're the validator running the network. So proof of work is a decentralized consensus mechanism that requires the members of the network to solve mathematical problems to help prevent any attacks within the network. And then also with proof of work, each transaction is completing through this mining process. And proof of work is mainly used in cryptocurrency mining for validating transactions and also mining new tokens. And overall, it requires a lot of energy. So the more people that use the network, the more expensive the fees are to complete the transactions, and also the longer the transactions are going to take. So with a network like Bitcoin, you're sacrificing scalability for more security. So going back to the list, most of these projects run on proof of work, but they have their own efficient version of proof of work. So most transactions are a lot quicker and a lot cheaper than Bitcoin. And XRP has its own consensus mechanism based on nodes. So XRP needs zero mining power when conducting transactions. So now we have generation 2, and the main project is Ethereum that really introduced smart contracts, Web3, and DeFi. So getting into Ethereum. So Ethereum is an open source, blockchain-based platform that creates and shares business, financial services, and also entertainment applications. Ethereum users pay fees to use decentralized applications, and these fees are called gas. And depending how big the transactions are, depend on the fees. Ethereum has its own currency, which is called Ether or ETH. And at the time of this recording, it's the second highest rated cryptocurrency network behind Bitcoin. So the main thing about Ethereum, it's really similar to Bitcoin, except only mainly being a medium of exchange. Now you can add decentralized applications and also smart contract functions to this network. And Ethereum was proof of work like Bitcoin, but it did transition to proof of stake, which is a different consensus mechanism that I'm going to get into in the next generation. So this is one of the main co-founders of Ethereum, and his name is Vitalik Buterin. And one of the main reasons why he created Ethereum, because he argued that Bitcoin needed a development language and also applications that can be built on top of the Bitcoin network. So Ethereum will be that alternative to that. So these generation 2 projects really saw a utilization of smart contracts, and smart contracts are self-executing contracts with the terms of agreement between a buyer and seller being directly written into lines of code. So smart contracts allow trusted transactions and agreements to be carried out among anonymous parties without the need for a central authority or other third-party systems. So a lot of the transactions and a lot of the applications built on Ethereum are all conducted by smart contracts, making it a more decentralized network than other traditional online applications. So now this goes into decentralized finance or DeFi. And DeFi uses emerging technology to remove third parties in financial transactions. And the components of DeFi are stablecoins, software, and hardware that enables the development of applications. DeFi applications give users more control over their money through personal wallets and trading services that cater to the individual. So essentially, a lot of DeFi applications are automated market makers, so the market runs on itself without a central party controlling the whole network. And now this goes into Web3. So Web3 refers to the decentralized web, and inside of it, there's decentralized applications and also decentralized finance. And the main form of currency within these applications are cryptocurrency assets or tokens. Web3 applications usually run on blockchain networks or other decentralized networks. They're based on a peer-to-peer node system, which are the servers that run the whole network. So overall, Web3 will provide increased data security, scalability, and privacy for users to combat the influence of large tech companies. So all these systems and functions are possible because of the Ethereum virtual machine. And the Ethereum virtual machine is a representation of a real computer that gives functionality to the whole network. This is a component of the ETH network that manages the deployment and execution of smart contracts. So the EVM uses a Turing-complete data system that allows the deployed contracts on the network to perform any task a regular computer can do. So overall, I like to say Generation 2 was the start of a new era in cryptocurrencies that really brought functionality to different cryptocurrencies instead of just mainly being a medium of exchange. So now we got Generation 3, and most of these are layer 1 blockchains that I see as competitors to Ethereum that really bring more efficiency and scalability to the networks. So the main competitor to Ethereum will be Cardano. And Cardano is really different from Ethereum because it's very scalable. You could do a lot more transactions per second, and the fees are a lot cheaper than Ethereum. And I also included Binance Coin, even though it's an exchange coin, because technically it has its own ecosystem. So Cardano is a proof of stake blockchain, which is different from Ethereum's proof of work. And Cardano's main goal is to be a more scalable and efficient alternative to Ethereum. And this is the founder of Cardano, and his name is Charles Hoskinson. And an interesting thing about Charles, he's actually one of the co-founders of Ethereum. But as time went on, he decided to create his own network because he just didn't have the same vision as the other Ethereum developers. So this post goes more into what proof of stake is. So a proof of stake is a mechanism where a person can mine or validate block transactions according to how many coins they hold. The proof of stake consensus protocol was made as an alternative to proof of work, and this mechanism addresses the scalability and environmental sustainability concerns around proof of work. So scalability refers to how well a system can manage increasing amounts of data. So blockchain scalability is how well it can handle an increasing number of transactions. So the generation 1 Bitcoin can do 7 transactions per second, while the generation 2 Ethereum can do around 30 transactions per second. And then Cardano is estimated to have around 250 transactions per second. So those numbers are like the base amount of transactions they can do. But as time goes on and there's different enhancements to be built on these networks, I believe these numbers will go up over time. These Gen 3 projects are very scalable and also energy efficient. So in my opinion, they're all good alternatives to Ethereum. So now I want to add generation 3.5, which are the layer 1 projects that we're mainly used to now. The standard generation 3 projects were mainly created around 2017 to 2018, but these generation 3.5 projects were mainly created around 2020 till now. So the main thing with these, they're all really similar to the Gen 3, but most of these projects want to solve the blockchain trilemma, which is solving scalability, decentralization, and security. And I would say most of these projects do fit into that criteria, but in my opinion, I think Solana would not in terms of the security part because of how many times the network got exploited, because it's a proof of history consensus. Now, the one project I really want to talk about in this category is Casper, because that one's a direct hard fork of Ethereum. So its prime use case is to be a more efficient version of Ethereum, and I personally always call it Ethereum 2.0. Okay, so Casper is a future-proof blockchain. This is a decentralized layer 1 proof of stake blockchain that's built off of the correct by construction specification. Casper is designed to accelerate enterprise and developer adoption of blockchain technology for today and also evolve to meet the needs of the future. So some key attributes of Casper: it's very scalable. So this is a truly scalable blockchain designed for real-world speed and security with very low and sustainable energy use. It's also very easy to use. There's multiple tools when creating on Casper, and it's actually built on WebAssembly, so you have multiple SDKs on here. It's optimized to be enterprise grade. So Casper is built so that enterprises and projects of any size can be chosen between public and private networks, making it a hybrid solution. The fees when conducting transactions are very low and predictable. And overall, it's future-proof, so as time goes on, it's going to scale and become more efficient. So Casper has some notable partnerships within the ecosystem. So here's one with intellectual property. So this partnership is going to provide NFTs to different businesses and governments, providing a proof of ownership solution in a digital economy. Also, you have a partnership with IBM, providing a hybrid blockchain solution. And then you also have a partnership with Casper and Amazon Web Services, which is going to help provide node infrastructure, and then also private network testing all on the Amazon Web Service. So the people that are building Casper and went to school or worked in all these institutions right here, these are areas of different backgrounds, so I can see a lot of solutions coming out of this ecosystem. Okay, so back to the list, Generation 3.5 are the projects that we're more familiar with today, and I just see them as better alternatives to Ethereum. And the main goal with most of these projects, they're trying to solve the blockchain trilemma. And if you didn't notice, I also added Corium, which is another project that I see having potential in the future. So now we're on to Generation 4, and how I label these projects. I label these projects as cryptocurrencies that don't utilize blockchain technology. They all utilize DAG technologies. And then we also have Holochain that uses its own network, which is the Holochain. So an interesting thing about DAG technologies, a DAG is a directed acyclic graph. So instead of a blockchain that just runs on a network of blocks that validate one at a time, a DAG can multiply transactions within each other at the same time, making it more scalable. So I'm going to show you a visual of how DAG technology works compared to blockchain. So So in each blockchain transaction, one block has to be completed to start another transaction. And with DAG technology, you can see transactions can be completed and then can multiply within each other. So I could see it being a lot more efficient and scalable in the long run. If blockchain has a limit to how scalable it can become. So on Navigating Crypto, they explain DAGs. So unlike a blockchain, which consists of blocks, DAGs have vertices and edges. Thus, crypto transactions are recorded as vertices. The DAG model is currently seen in the industry as a possible substitute for blockchains in the future due to its efficiency in data storage and processing of online transactions. With nodes being developed simultaneously, transactions can likewise be processed faster. Developers are eyeing DAG as a better, more secure solution that can improve a network's usability once it becomes more scalable. So even though there are a lot of scalable and efficient blockchain networks, I think it's still important to look at some DAG technologies because we don't know the full potential of DAGs because they're not fully utilized yet. And the main thing with DAGs, such as Hedera Hashgraph, the more people that utilize the network, the more scalable it becomes. So these projects can be really big powerhouses in the future. So a quick explanation of Hedera Hashgraph. Hedera Hashgraph is a crypto network seeking to serve as a platform on which anyone can transact and deploy applications. Hedera is the only public ledger that uses the Hashgraph consensus, which is a faster, more secure alternative to blockchain consensus mechanisms. HBAR is the native energy efficient crypto of the Hedera public network. HBARs are used to power decentralized applications and protect the network from malicious actors. So a more brief explanation of Hedera. Hedera is a fully open source proof of stake public network and governing body for building and deploying decentralized applications. It offers multiple solutions such as Solidity based smart contracts. It has its own consensus service and also a token service where you can create different native assets on the network. So Hedera is uniquely fast, energy efficient, which makes it carbon negative. It's very secure. And all these combined factors are part of the Hashgraph consensus algorithm. So down here, it shows all the solutions and use cases that Hedera Hashgraph brings. And they're all really similar to the layer 1 blockchains that I showed you that are generation 3 and also generation 3.5. But the fact that it's a DAG technology, it can bring a lot more efficient solutions in the long run. So an explanation of IOTA's Tangle. It's really similar to the Hashgraph consensus and the Hedera network. But the main thing with the IOTA's Tangle, it's mainly made for Internet of Things solutions. So now we're going to get into Holochain. So Holochain helps by creating an alternative to the dominant centralized systems of the internet, protecting our ability to make our own decisions, and giving trustworthy information that we can act on. We call this digital agency, and we believe it will give us the power to face today's complex problems together. So a Holochain is a chain like no other. You can simultaneously validate on-chain experiences, and you have a fully distributed peer-to-peer application framework. This makes Holochain unique in the world of software and distributed networks. So here's a quick and more brief explanation of what Holochain is. So a Holochain brings data integrity. Application data is created and validated using one shared set of rules that apply to everybody. We use cryptography to ensure that data cannot be tampered with once it has been created, no matter where it is or stored. It brings solid frameworks. It has a database for storing, organizing, and finding data spreads across many computers, so nobody has full control over it. It has its own framework of decentralized applications. It's going to transform the kind of web applications controlled by a central corporation. So the main thing with holochains compared to blockchains, a blockchain has one universal consensus mechanism, but now with holochains you can have multiple consensus mechanisms that work for the users that communicate with each other. Some other key things about Holochain, it's really similar to DAG technologies in the fact that the more people that utilize the network, then the more it scales. And when creating decentralized applications, it's more local based and user friendly. And the fact that you don't need your own digital token to run on a Holochain, it's going to make it more user friendly. And also when creating on here, it's built on WebAssembly, so you have multiple SDKs on here. And overall, it wants to be naturally resilient, so it's not going to be just relying on the Byzantine fault tolerance that many blockchain networks use. Now it's going to have multiple architectures within that system. These systems were all created by utilizing physics and biology to produce a more large-scale, high-performance, and distributed system. So here's a visual of how Holochain works. So you can see blockchain is mainly relying on the network consensus and also the validators within the system. Holochain's consensus is relying on the people that utilize the nodes within the whole ecosystem. So in my opinion, it brings a more scalable network because you're not just relying on one consensus mechanism, and then you're not relying on the validators to complete the functions within the network. So these are the Gen 4s. Let me know what you thought about my list. I want to know if you think DAG technologies are more efficient in the long run, or do you think Holochain is more efficient? Or overall, you think blockchain is here to stay and you think that's going to be the more efficient in the long run? Alright, so that's the end of the video. Thank you so much if you made it this far. I really appreciate it. So this video is a brief overview of all the innovations that happened between the cryptocurrency space from the start to now. So some key points of how I listed these generations. Generation 1 is primarily a medium of exchange platform that is decentralized, that got its use from getting away from the centralized systems. Generation 2 brought smart contract capabilities and web development to these decentralized networks. Generation 3 became a more scalable and energy efficient to the Generation 2. Generation 3.5 systems are the one that we're more familiar with today, and most of these want to solve the blockchain trilemma, which is bringing more scalability, decentralization, and security. And then Generation 4 I made as the decentralized networks that run on DAG technologies, or also Holochain, that are more efficient than blockchain networks. So I want to hear what you guys think about my list. Did I forget some projects? Do I need to add some more? Did I leave out any key concepts that are important to these generations? And do you think DAG technologies and Holochain technologies have the capability of taking over blockchain? I'm really curious to hear what you guys say. So it's your boy Metapunk. Thank you for watching, and I'm signing out.